Okay, so this surface, there's a typo. What I mean is r of st is equal to st s squared plus t squared. So in other words, this is the paraboloid, and we have the Cartesian coordinate parameterization. Okay, so we want to find the normal and tangent vectors. Since we're given the parameterization, we'll begin with the tangent vectors. So v1, this will be one tangent vector. This can be equal to the partial derivative of r with respect to s evaluated at 1, 1. What is this? Well, the partial derivative of r with respect to s is 1, 0, and then 2s. So if s is equal to 1, that's just equal to 2. And then v2, this we can take to be the partial derivative of r with respect to t, also evaluated at 1, 1. And similarly, this is 0, 1, 2. Okay, so v1 and v2 are two tangent vectors. So all tangent vectors are of the form c1 times 1, 0, 2 plus c2 times 0, 1, 2. Okay, so now let's find a normal vector and then the equation for the tangent plane. So the normal vector we can take to be v1 cross v2, or this is I, j, k, 1, 0, 2, 0, 1, 2. And what is this? The first component is going to be the determinant of this 2 by 2 matrix. So that's 0 times 2 minus 1 times 2. So this is minus 2. Then the next component is going to be minus the determinant of the 2 by 2 matrix formed by the outer two columns. So that's 1 times 2 minus 0 times 2. So the determinant is 2. With the minus sign, it's minus 2. And then finally, we're going to look at the determinant formed by the first two columns. That's equal to 1. Okay, so this is the normal vector. And then the equation for the plane is now pretty simple. It's going to be minus 2 times x minus r of 1, 1. Okay, so now to find the equation for the tangent plane, notice that r of 1, 1 is equal to 1, 1, 2. So the equation for the tangent plane is going to be, or an equation for the tangent plane is minus 2 times x minus 1 minus 2 times y minus 1 plus z minus 2 is equal to 0. Okay, and so there you have it. We were given the parameterization of a surface. We were able to find the normal vector, or the tangent vectors, and from that we could find the normal vector. There's different ways you can do this, and we're going to see more examples when we actually start doing surface integrals.